Swimming pool equipment, such as pumps and motors, can generate unusually high fault currents compared to other electrical circuits. This is due to several factors. Firstly, low impedance. The water in the pool provides a low impedance path for current to flow, reducing resistance and increasing fault current. Secondly, large motors. Swimming pool pumps and motors are typically high horsepower devices that consume significant amounts of current. Thirdly, long circuit runs. The electrical circuits connecting the equipment to the main panel can be relatively long, which increases resistance and inductive reactance. However, this also reduces the overall impedance of the circuit, allowing more current to flow in the event of a fault. If circuit breakers are not rated for the potential fault current, they may fail to interrupt the current effectively. This can result in electrical fires. The excessive current can overheat the circuit breaker and surrounding components, leading to a fire. It can also result in equipment damage. The high fault current can damage connected equipment, such as pumps and motors. Finally, it can result in personal injury. If the fault current persists, it could create electrical shock hazards or arc flash incidents. Manufacturers specify a 10,000 amp interrupting rating for swimming pool circuit breakers to ensure that they can safely handle the potential fault currents. This requirement is based on extensive testing and field experience to minimize the risks described above. The 10,000 amp interrupting rating specified for swimming pool equipment is essential for ensuring the safety and functionality of the circuit. It reduces the risk of electrical fires, equipment damage, and personal injury by ensuring that the circuit breakers can effectively interrupt high fault currents. Compliance with manufacturer specifications is crucial for safe and reliable electrical installations. The reason for this requirement boils down to the unique electrical environment created by swimming pools. Water, being a conductor, significantly lowers the impedance of the circuit. Impedance is the total opposition to current flow in an alternating current circuit, similar to resistance in a direct current circuit, but also includes the effects of inductance and capacitance. When a fault occurs, like a short circuit, the current will take the path of least impedance. In a swimming pool environment, the water offers a very low impedance path compared to other grounded elements. Because of this, fault currents can be significantly higher than in typical residential or commercial circuits. Secondly, pool pumps and other equipment are typically powered by relatively large motors. These motors draw a substantial amount of current during normal operation. In the event of a fault within the motor or its associated wiring, the current can surge to many times its normal operating level. The higher the horsepower of the motor, the greater the potential fault current. Thirdly, the distance between the main electrical panel and the pool equipment can be considerable. While longer wire runs generally increase resistance, they can also introduce inductive reactance. Inductive reactance is the opposition to the change of current flow in an alternating current circuit. While it might seem counterintuitive in certain situations, the overall effect can be a lower overall impedance, thus contributing to higher fault currents. The combination of these factors, water's low impedance, large motors, and circuit characteristics creates a scenario where fault currents can easily exceed the capacity of standard 5,000 amp interrupting rating circuit breakers. When a circuit breaker with an inadequate interrupting rating is subjected to a fault current beyond its capacity, it can fail in several dangerous ways. 1. It might not trip at all, allowing the fault current to continue flowing. 2. It might trip, but not quickly enough to prevent damage. 3. It might trip violently, creating an arc flash and potentially exploding. In any of these scenarios, the consequences can be severe, including electrical fires, equipment damage, and personal injury or even death. The higher 10,000 amp interrupting rating provides a safety margin to ensure that the circuit breaker can reliably and safely interrupt the fault current before any of these dangerous situations occur. Think of it like this: a standard circuit breaker might be able to handle a small electrical surge, but a high interrupting rating circuit breaker is designed to handle a massive electrical surge, like a dam designed to withstand a major flood. The National Electrical Code, or NEC, provides general guidelines for circuit breaker interrupting ratings. However, manufacturers of prefabricated pool equipment panels often specify higher interrupting ratings because they have tested and listed their equipment to meet specific safety standards. This listing ensures that the equipment has been evaluated by a recognized testing laboratory and meets certain performance criteria. The manufacturer's specification takes precedence over the general NEC guidelines because it is specific to the equipment and ensures that all components work together safely. It's crucial to always follow the manufacturer's instructions and use the specified components when installing electrical equipment. Using a circuit breaker with a lower interrupting rating than specified can void the warranty and, more importantly, create a significant safety hazard. The 10,000 amp interrupting rating is not just an arbitrary number. It's a carefully determined value based on engineering calculations, testing, and field experience. It represents the minimum level of protection necessary to ensure the safety and reliability of the swimming pool electrical system. Ignoring this requirement can have serious and potentially deadly consequences. Therefore, always adhere to the manufacturer's specifications and use the correct circuit breakers to protect swimming pool circuits. It is worth to consult with a qualified electrician to make sure all requirements are met and the system is up to local codes. Furthermore, regular inspections are useful to catch any issues before they cause harm. The inspection should include the condition of the wiring, circuit breakers, and other electrical components. It is a good idea to replace any damaged or worn components immediately. Ground fault circuit interrupters, or GFCIs, should be used in all swimming pool circuits to provide additional protection against electrical shock hazards. GFCIs are designed to detect small imbalances in current flow and quickly trip the circuit, preventing serious injury. In summary, the 10,000 amp interrupting rating requirement for swimming pool circuit breakers is a critical safety measure. It is based on the unique electrical characteristics of swimming pool environments and the potential for high fault currents. Adhering to the manufacturer's specifications, using the correct components, and conducting regular inspections are essential for ensuring the safety and reliability of swimming pool electrical systems. Remember, electrical safety is not something to be taken lightly. Always follow the rules and guidelines to protect yourself, your family, and others from the dangers of electricity. Ignoring these requirements can lead to serious consequences, including electrical fires, equipment damage, and personal injury. Prioritize safety by following the manufacturer's specifications, consulting with qualified electricians, and conducting regular inspections to ensure the reliability of swimming pool electrical systems. The high fault currents can result from several factors, including the close proximity of water, which is a conductor and reduces impedance, and the large motors which draw substantial current. The combination of these elements can create fault currents that surpass the capacity of standard 5,000 amp rated circuit breakers. A circuit breaker is designed to protect an electrical circuit from damage caused by overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. The interrupting rating of a circuit breaker specifies the maximum fault current that the breaker can safely interrupt without being destroyed or causing an electrical arc. When a fault occurs, the current flowing through the circuit can increase dramatically. If the circuit breaker's interrupting rating is lower than the actual fault current, the breaker may fail to interrupt the current effectively. This can result in serious consequences, including electrical fires, equipment damage, and personal injury. In the context of swimming pool equipment, the presence of water creates a low impedance path for current to flow. This means that in the event of a fault, the current can easily flow through the water, increasing the magnitude of the fault current. Additionally, swimming pool pumps and motors are often high horsepower devices that consume significant amounts of current. When these motors experience a fault, the resulting fault current can be very high. For these reasons, manufacturers of swimming pool equipment often specify a 10,000 amp interrupting rating for circuit breakers used in these applications. This higher rating ensures that the circuit breaker can safely interrupt the fault current even in the presence of water and high horsepower motors. Using a circuit breaker with a lower interrupting rating than specified by the manufacturer can create a significant safety hazard. If a fault occurs and the circuit breaker cannot interrupt the current effectively, the excessive current can overheat the circuit breaker and surrounding components, leading to a fire. The high fault current can also damage connected equipment such as pumps and motors. In addition, if the fault current persists, it could create electrical shock hazards or arc flash incidents. An arc flash is a dangerous electrical explosion that can cause severe burns, blindness, and even death. To mitigate these risks, it is essential to use circuit breakers with the correct interrupting rating for swimming pool equipment. Following the manufacturer's specifications and consulting with a qualified electrician can help ensure that the electrical system is safe and reliable. In summary, the 10,000 amp interrupting rating specified for swimming pool equipment is necessary to protect against the high fault currents that can occur due to the presence of water and high horsepower motors. Using circuit breakers with the correct interrupting rating can prevent electrical fires, equipment damage, and personal injury. The manufacturer's specifications for circuit breakers in swimming pool equipment panels is typically higher than standard circuit breakers due to the potential for higher fault currents. The presence of water, large motors, and long circuit runs can all contribute to increased fault currents. Inadequate interrupting ratings can lead to electrical fires, equipment damage, and personal injury. Therefore, it is crucial to comply with the manufacturer's requirements and use circuit breakers with a 10,000 amp interrupting rating. The purpose of a circuit breaker is to protect an electrical circuit from damage caused by excess current from an overload or short circuit. The interrupting rating is the maximum fault current that a circuit breaker can safely interrupt. If the available fault current exceeds the interrupting rating of the circuit breaker, the breaker may fail catastrophically, potentially causing an electrical explosion, fire, or other hazards. Water in and around swimming pools creates a low impedance path for electrical current. This means that in the event of a ground fault, the current will tend to flow through the water, potentially exposing swimmers to electric shock hazards. The increased conductivity of water also means that fault currents can be higher than in other electrical circuits. Swimming pool pumps and motors are often high horsepower devices, which can draw significant amounts of current. In the event of a fault, the fault current can be much higher than the normal operating current of the motor. The longer the electrical circuit, the greater the impedance. However, even with increased impedance, the available fault current can still be high enough to exceed the interrupting rating of a standard circuit breaker. If a circuit breaker fails to interrupt a fault current, the excessive current can cause the breaker to overheat and melt. This can lead to an electrical fire or explosion. High fault currents can also damage electrical equipment, such as pumps, motors, and wiring. This can lead to costly repairs or replacements. If a fault current persists, it can create a risk of electric shock or arc flash. An arc flash is a dangerous electrical explosion that can cause severe burns, blindness, and even death. To protect against these hazards, manufacturers of swimming pool equipment often specify a 10,000 amp interrupting rating for circuit breakers. This higher rating provides a greater margin of safety and ensures that the circuit breaker can safely interrupt fault currents in a swimming pool environment. It is important to note that the manufacturer's specifications are based on extensive testing and analysis. They take into account the specific characteristics of the equipment and the potential hazards of the environment. Therefore, it is crucial to comply with the manufacturer's recommendations and use circuit breakers with a specified interrupting rating.